The ideal gas law is the most important law in the entire gas law unit. And so the ideal gas law is located right in the center of your formula sheet. And this video is really going to walk you through each individual variable, and on top of that, specific units that must be used for each individual variable. So please make sure that you are labeling your formula sheet or putting this down in your notes, just as I'm laying this out for you in the video. Okay, I'm going to start with what each of the individual variables refer to. And so the P in the ideal gas law clearly is going to represent pressure. The V in the ideal gas law is going to represent volume. Lowercase n always represents moles. I'm going to come back to R in just a second. I'm going to move over to T. T represents temperature. So you've used all of these variables before in some way or another. You looked at Boyle's law, and you looked at the relationship between pressure and volume. You looked at Charles's law, and you looked at the relationship between volume and temperature. And the last thing that you completed prior to spring break was looking at Avogadro's law, where you looked at the relationship between volume and moles. Going back now to the ideal gas law, your units of pressure, your units of volume, your units of temperature, and clearly N represents moles, that's its own unit. Those units are going to have to be very specific. You can no longer just pick and choose, or not an issue if you have milliliters and liters. So here's what I mean by that. Anytime that you're going to be dealing with units of pressure, your units must be in ATM. Anytime that you're going to be dealing with units of volume, your unit that you're going to then put into your formula must be in liters. N is not much of an issue. That is moles, and moles is its own unit. Just as a reminder, we may come across some situations where you're given a quantity in grams. You're going to then need to take the molar mass, multiply it to the grams to get your number of moles. And remember, anytime that comes up in any of the problems, we're going to walk through that together step by step. Lastly, for temperature, if you will remember back when you looked at Charles's law, your temperature had to always be converted to Kelvin. And so Kelvin and moles, you're pretty much used to that from prior formulas that we've covered. For volume, from now on, you can't have milliliters or any other version of a volume unit. It must be in liters. Pressure can't have torr or millimeters of mercury, any of those other units that we talked about, like Pascal and kilopascal. Everybody has to be converted to ATM when it's plugged into the formula. And so any of the units that I've underlined here in red, those are the only units that you can use inside the actual equation. So now I want to take a moment and focus on the variable R. So R is a constant, and R is a constant that includes volume, pressure, temperature, and moles. It's the first constant we've ever used that has more than one unit or multiple units, and we've not really been using constants before up until now. So a constant is just any time that you see this variable in the equation, you're going to continuously and consistently just plug in the same value. So this is the value of R. It's 0.08206. And it has 4 units The numerator units are always liters times ATM over Kelvin times mole. If you look at your formula sheet, you have R labeled for you right next to the ideal gas law. I'm just rewriting it out for you in this video. So the last constant that we had used was just the given value of moles and Avogadro's number, the given value of Avogadro's number, which was 6.022 times 10 to the 23rd. This constant for R always represents one value, 0.08206, and it always has 4 different units: liters times ATM over Kelvin times mole. I want to clarify for you right now that if you wrote out your units of R as 0.08206 and you just said ATM times liters over moles times Kelvin, that works as well. That's not an issue because that's just multiplication. That's the order. What you can't do is flip the denominator with the numerator or vice versa. So you're going to always see me write it as liters times ATM over Kelvin times mole. And you notice I'm saying liters times ATM over Kelvin times mole, but I'm not putting a little multiplication symbol between them. That's not necessary. You can add that if you like to. Just make sure you're understanding now that the reason why we could only use specific units for pressure and volume and moles and temperature was because of R. So R now, because it's a constant, it's going to consistently force us to have units of ATM for pressure, units of liters for volume, units of Kelvin for temperature, and of course moles has to always be in mole. Otherwise, when you're putting in all your information in your formula, units won't cancel. That's the issue. So we're going to walk through each example step by step, but this part right here of labeling all the individual units that you need for each one and understanding what is the actual number for R, and just being comfortable knowing that you are going to have to isolate variables in the ideal gas law, that's what's most important for today. This constant is something that would be given to you on any quiz or test. You do not need to memorize it. Remember, this entire formula sheet is what you would be given for any quiz or test.